Hello and welcome to another episode of Astrophysicist Reacts with me, astrophysicist Dr. Becky Smethurst. This is the show where we pick out the science from the fiction in popular sci-fi. Why? Because we're nerds and we like to learn stuff. Now we've done Stargate in this series and we've done Star Trek and now it's time for the ORVILLE, the sci-fi comedy drama from Seth MacFarlane. Now, I've never seen the ORVILLE before, unsurprisingly balancing full-time astrophysics research with making videos on YouTube and also getting enough sleep at night doesn't really give me enough time to binge watch shows. So on Twitter and Instagram, I asked all of you for suggestions of which episode of the show to watch from an astrophysicist's perspective. I think season 3, episode 6, Twice in a Lifetime, popped up the most, which after a little bit of research just seems to be like a fan favorite episode. There's lots of character development and stuff. There's also a massive, time travel storyline in that. And you know what? No one likes a time paradox. And let's be honest, I could never talk about time travel better than Minute Physics did in their iconic time travel in fiction video. Honestly, watch it if you've never seen it. Season 1, episode 11, New Dimensions, also popped up a lot. And while I was very tempted by a Flatland-inspired episode, I was also warned off from watching any episode from season 1. So I decided against that one as well. And then after that, there was many requests for season 2, episode 14, The Road Not Taken. And it was Space by Storm on Twitter that eventually convinced me to do this one. They know the way to my heart is a black hole. So let's dive into this. Let's react to the ORVILLE, season 2, episode 14, The Road Not Taken. So they're supposedly inside an ice moon right now. And when they said that before, I could take us inside an ice moon, I was a bit like, how are you gonna do that? Because when we think about the icy moons of Jupiter and Saturn, what they have is this really icy crust, and it's a very, very thick crust as well. Now, obviously, none of us really know until we go there, what that icy crust would look like, if it would have caverns like this, if it was cracked. I mean, and some of the surfaces of them do look like they might have some form of caverns of sort, but I wouldn't call that, if I'm being pedantic, which, let's be honest, that's what this entire series is about, right? If I'm being pedantic, I wouldn't call that being inside an ice moon. Inside an ice moon to me would be being completely under the crust. And I thought that's what they were going to do. They were going to some sort of drill through the crust. I don't know. It's sci-fi. So some sort of laser thing of some form, and then be underneath the sort of liquid ocean that was under that icy crust. And then that's where they were going to reset their quantum drive. Wait, I'm yet to find out what that is. I presume it's some sort of in Star Wars, hyperspeed or something like that. It's some way of them probably going faster than light travel. Don't know what that really has to do with quantum necessarily. I'll keep watching.
Quantum drive is back online. All right, get us out of here.
Yeah, so what they're calling quantum is, I think they're faster than light speed travel. All sci-fi shows have in some way to, just be able to move forward the plot and not be it's 10,000 years to get to that nearest star system. And I'm getting very strong, MCU, Marvel Cinematic Universe vibes from the fact that they've just called it quantum.
Do you guys just put the word quantum in front of everything?
So quantum physics is just the physics of the very, very small. And in my head, that doesn't necessarily link to faster than light speed travel in terms of physics as we understand it right now. So we're saying that in terms of physics as we understand it right now, we don't think it's possible to go faster than the speed of light. That's what Einstein's special relativity tells us. Essentially, as you approach the speed of light, you have to have infinite energy and infinite mass. And it's sort of this hard limit in the universe for anything, that nothing can go faster than the speed of light. I've made videos on this before if you want to check those out to sort of look at this in more detail. Obviously, as I said, all sci-fi shows run into this problem and they just have to be don't think about it. We've somehow figured out faster than light speed travel. But calling it a quantum drive, there's not really a link there between sort of the realm of the very, very impossibly tiny and then faster than light speed travel. In my head, anyway. Of course, what do I know? We're still looking for, a theory of quantum gravity, linking Einstein's theory of general relativity, our best theory of gravity, with quantum physics. We don't have that theory yet. Perhaps at some point in the future, someone cracks that, and that somehow linking general relativity and special relativity manages to give us faster than light speed travel. Hence, quantum drive. I know, I'm overthinking it far too much. I'll just keep watching.
It was part of your crew.
Okay, well, that's a much more appealing version of events, but it's not reality.
Yes, it is. In an alternate timeline.
Oh no. Is this episode also going to be about time travel of some form? Like alternate timelines? It's like I'm watching Community all over again.
Nice times like this. I wonder what's happening in the darkest timeline.
I feel like it's worth noting here, and I feel like I say this a lot when I watch these sci-fi things, that asteroid fields like this are never this dense. And fair enough, okay, this might not be an asteroid field. It might be, in terms of where it was clustered, it could have been like a moon that was like blown up in some way and fragmented. Fair enough, that might be slightly denser, but still not this dense, I don't think. But like in terms of like the density of, say, the asteroid belt in the solar system, for example, yes, there's a lot of asteroids in it, but it's very sparse. Like if you were to fly through the asteroid belt, you probably wouldn't even notice unless you happened to do a flyby of a very specific asteroid. And that's why we can send probes very easily to Jupiter and Saturn, because most of the asteroid belt is just empty space.
We can't outrun them. We need somewhere to hide.
What about the black hole?
Are you nuts? We'll be crushed by the gravity.
Not if we slip just inside the event horizon. They won't see us because light can't escape.
What the hell?
I mean, this might be negated by the fact that they have faster than light speed travel with the quantum drive. But in reality, like if you go past the event horizon, that sphere around the black hole where we don't get any more light from it because you have to be traveling faster than light to escape it, and it's not possible under our current laws of physics and our understanding of the universe to travel faster than the speed of light. When you get inside that event horizon, time and space start to do weird things. Like there is no other future for you past that point that doesn't end up with you being at what we would at least mathematically describe as the singularity, where all of the matter is crushed down into an infinitely small and infinitely dense point. Like the future, like beyond the event horizon, the future is no longer a direction in like time, like the fourth dimension of time, as we often say. The future is a direction in space. So if you were to like accelerate your spacecraft, like turn away from the singularity and try and accelerate out of the black hole towards the edge of the event horizon again, you would still get turned back towards the singularity. Like your spacecraft could not stop that from happening. Hence why the future is a direction in space, not just in time. Your spacecraft wouldn't be able to stop that happening in the same way that your spacecraft wouldn't be able to stop tomorrow from coming. If you want to understand this a little bit better in terms of like what happens when you fall into a black hole, go beyond the event horizon, what someone watching you fall into a black hole would actually see, I do actually talk about this in, I think it's chapter 13 of my book. Yes, 13. You Can't Stop Tomorrow Coming is the chapter of the book that I talk about that more in, if you want to check that out. I mean, I will give them props though that their rendering of a black hole looks pretty accurate. Obviously it was Interstellar that first did this. They took astrophysical simulation of sort of like where the particles would be and where light would be coming from around a black hole, and actually fully rendered it as what you would visually see. So it looks spectacular. We've known this for a while, that essentially what would happen to the light behind the black hole, so behind that sphere of the event horizon, all of that light would get bent around the black hole. So you would see this ring around it, and then, yeah, you would have this accretion disk as well, which was sort of matter that was slowly spiraling into the black hole as you have all of these collisions, like the collisions between balls on a pool or a snooker table that give energy to some and take away from others. And as one particle collides with another and lose energy, it will fall towards the black hole. And those that gain energy will stay in orbit around it. Hence why you end up with this huge big disk of material that's spiraling around like they're showing here. So props to them for getting that. Very, very nice.
Wow.
I mean, that is literally a black hole physicist's dream. They're seeing what's inside the event horizon, something that we don't know because we don't get any information from beyond that, because nothing can travel faster than light, so not even light can escape, and light is how we transfer all information between us. All signals are transferred, encoded on light. And you'd never be, even if you were able to fly into the event horizon and somehow avoid getting like spaghettified, where the gravity is obviously so much stronger at like your feet than your head. If you're falling in feet first, you get stretched out like spaghetti. If you have a spaghettification proof spacecraft, which it appears that they do here because they're absolutely fine. Again, sci-fi. But if they had a spaghettification proof spacecraft, even if they flew into the event horizon, if they couldn't travel faster than the speed of light, you couldn't get back out again. And therefore you couldn't tell anybody what you had seen. And so seeing inside right now, we have no idea what that looks like. So obviously the graphic designers here were allowed to just go to town on what they thought it would look like. But it looks like they've sort of got everything going towards, what would be mathematically described as a singularity. But, it could be that there's something else inside the event horizon, some exotic form of matter that we don't know about that's somehow resisting the crush of gravity down. It just so happens you'd have to be traveling faster than the speed of light to escape it, hence why you get that event horizon where we can't observe anything that's going on beyond it. We just don't know. It's one of those things that you kind of have to resign yourself as a scientist to maybe never knowing.
This deep inside the gravity well of a black hole, time moves more slowly for us than it does for them. For every second we're in here, a couple of hours pass out there.
So, when he says this deep, if they've supposedly parked just inside the event horizon, and then you've got, craft on the other side of the event horizon that they're now watching that they can see, but those craft can't see them, like the time dilation between those 2 points wouldn't actually be that much different, because in terms of the place you are in space, in terms of distance you're away from that, as we describe it mathematically, the singularity in the center, that distance hasn't changed much, and therefore the time dilation between those 2 points wouldn't have changed much either. Apparently whatever engine they're using is fine in space, and it's fine underwater. And the fact that, there's no pressure in space, and the fact that it's a vacuum compared to the fact that it's incredible pressure underwater, there's no problem there either. I'm not an engineer, but this smells suspect to me. Any engineers watching want to comment down below? Much appreciated.
Every individual K-line has the equivalent of a neural identification code. It's how they know who's who and all the crisscrossing signal packets.
Small point. Again, overthinking this, but I see this in a lot of sci-fi, and that is that you can see like stars out of the window of whatever ship that you're on, which is not really that realistic if you think about it. Like, think about if you're in your house at night with the lights on in a room. You can't usually see the stars out of the window because they're just too faint compared to the bright lights of the room that you're currently in. And also there's reflections off the windows as well. Usually you have to turn the lights off and even maybe sort of like trap yourself behind the curtains to see out of the window out to the sky. Yes, you're in space. There's less atmospheric effects in terms of distortions and making stuff just that slightly bit fainter, and obviously light pollution and all that kind of stuff. But still, if you're in like a bright meeting room with all of the lights on, you wouldn't be able to see the stars out of the window.
Okay, I gotta go to engineering to feed juice from the quantum drive. I need you to monitor the graviton levels. Let me know if they drop below 1.7 GeV.
We got it. Go.
1.7 GeV, so that's a gigaelectron volt. An electron volt is a unit of energy, not a voltage, as it's often confusing, but it's the energy that a single electron gains when it is accelerated through an electric field of just 1 volt. So weird unit, but it's good for when you're talking about particles. And sometimes you'll use it sort of interchangeably when people talk about energy or mass as well. So for example, like small particles masses are sometimes expressed in terms of electron volts, because all you have to do is divide it by c squared, because energy and mass are equivalent. E equals mc squared. So if you've got the energy, you want the mass, divide by c squared and you get the mass. So to give you some context of where 1.7 giga electron volts sort of sits in terms of energy, it's definitely above sort of like the smallest particles sort of energy, but it's not quite as much as some of the heaviest of particles energy, like sort of like top quarks, like the heaviest of quarks. And once you've had gigaelectron volts, you get into teraelectron volts. And those are the energies that things like the Large Hadron Collider, the big particle accelerators in Switzerland, just under Switzerland and France, at CERN reach. They get up to like tens of tera electron volts. Like I think sort of like 15 tera electron volts is usually the number that's quoted, although I'm not a particle physicist, so I don't have those numbers like to hand, but it's around about that number. So just to give you an idea of like, in case you're wondering and being like, where does 1.7 gigaelectron volts lie on the scale of electron volts? That's kind of where it lies.
I'd love it.
I mean, I have no idea what went on in terms of characters in that, but I kind of enjoyed the episode. It gave me like massive, like Firefly vibes, and I binge watched Firefly when I was at university and absolutely loved it. So if there's something that can fill the hole that Firefly left, then I'm definitely going to be watching the rest of the episodes in this series. As for the science in it, I definitely think that the ORVILLE leans more on the side of fiction than the science side of things. Obviously all sci-fi, you know, has to decide which side of that line that they do fall on, and at some point you do have to sacrifice some science for the sake of plot. But you can tell that, you know, where they could get it right, they did, like with the visualization of the black hole, for example. And also it was interesting to think about, okay, in this fictional scenario where they can go faster than light speed travel, you know, what would that mean in terms of black holes? And you could go beyond the event horizon, and fair enough. So that was really fun to see. If you want me to react to your favorite sci-fi series or movie or even book, let me know down in the comments below which one, or over on social media, Twitter, Instagram, TikTok. You'll find me in all of those places. But before we get to the bloopers, I just want to say a huge big thank you to Brilliant for sponsoring this week's video. Brilliant is a website and app that allows you to learn new concepts in science and maths and computer science with interactive hands-on courses that get you to learn by doing, which is personally the way that I learn best. There's new content added every single month, and there's something for everybody. For example, if you want a better feel for what is real science and what is the fiction while watching sci-fi, you know, most of it just comes from physical intuition of knowing, you know, what sounds scientifically legitimate and what sounds like just jargon words all thrown together. You can work on that intuition with Brilliant's everyday physics course that takes you through loads of basic concepts in physics, but from an everyday perspective. So that even though the concepts might be new to you, the context that it's in is very familiar, hopefully making it much easier to gain that physical intuition. If that sounds like something you'd be up for, head to brilliant.org/Dr. Becky. You can click on that link in the video description below and you can sign up completely for free. Plus the first 200 people that go to that link are going to get 20% off an annual premium subscription. So thank you so much to Brilliant for sponsoring this video. Now, roll those bloopers. I mean, I say roll those bloopers, but I feel like with a video like this, it's not really bloopers, it's more like my snarky comments that I got from the main video because it wasn't actually about science.
What? We almost got killed getting this thing, and you're having a Twinkie?
I wanted a Twinkie. You want half?
Yes, I want half.
You know, I still don't know what a Twinkie is. I've never had one. I'm putting that out there. What is a Twinkie?
And I ended up doing something that changed history.
What?
I said no to a second date.
Huh?
I didn't know to a second date. Oh my god, is this some sort of like weird moral story? You know the way that like Star Trek's supposed to have a moral with everything, and the moral here is like, no women should turn down men because you could end in the whole universe's destruction. Oh, please tell me that's not true.
According to the chronometers, 2 full days have passed.
Man, how was your weekend?
Quantum drive is back online.
This quantum drive, very flaky, like it's offline and back online again. Very convenient moments for the plot. Also, I think about the ORVILLE, like I hear the word, and wasn't ORVILLE like a big bird puppet? Like I've not imagined that, right? Like a big bird with a high squeaky voice, like me, 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 me. ORVILLE bird. ORVILLE the duck was the most famous puppet. Puppet? Hello, puppet. He was the most famous puppet often used by the ventriloquist Keith Harris and was named after ORVILLE Wright. He was a green duck. Oh, I'm going to lose so much time now watching old ORVILLE. Oh, I wish I could fly. Oh, I remember this.
My sadness will end, but it won't. It
this ever a thing? Like, how is this popular? How did this make it to Christmas Top of the Pops in 1982?